So welcome to video problem 14 where we will use Biot-Savart's law to determine the B field for a uniform finite steady line current in free space. You can see the configuration here. It's a linear finite conductor which carries a current I which is positive, and the length of our conductor is equal to 2L. It is located in free space with free space permeability μ0. The objective is to determine the field at this observation point P. We introduce a cylindrical coordinate system with these coordinates that you can see here, and we introduce it so that the conductor is located along the z-axis as shown here, and that the observation point has these coordinates here. So we are essentially determining the field at a radial distance r from the origin, which is here, to the observation point P. We know that steady currents only can exist in closed circuits, so this linear conductor must somehow be closed by another conductor, but we don't know the rest of this circuit, so there is no symmetry that we can exploit to determine the B field in this particular case. That means that we cannot use the usual Ampere's law, which requires symmetry, but we instead must resort to Biot-Savart's law, which is shown here. This is our configuration, and this is again Biot-Savart's law, and here it is essential to understand that dl is a vector differential element on our current conductor. R vector is the position vector of the observation point, and R prime is the position vector of the source point. So we will have to identify these terms that we can plug in the integrand and then do the integration. dl is obviously in z direction and is given by the expression here. R is the vector from the origin to the observation point in circular cylindrical coordinate system. It's given by the expression here. R prime goes from the origin towards the source point, obviously here in z direction, and then the magnitude z prime, which will vary as you integrate along the conductor. The difference vector from the source to the observation point is given by the expression here, so that you very easily get the magnitude of this vector, which is also entering into Biot-Savart's law. The cross product between our dl and the difference vector is shown here. Z hat cross r hat will be in the direction of phi hat. Z hat cross z hat will give you 0, and then you can plug everything inside of the Biot-Savart's law, and you do the integration in z from minus L to L to arrive at this final result for the B field for our linear conductor of length 2L carrying current I. So we are essentially done with our problem. I can ask you to determine the above field by first obtaining the vector magnetic potential A and then taking the curl of the resulting vector expression. Also, I would like you to evaluate this field for R much smaller than the length of your conductor. That essentially means that you are very, very close to your conductor, and then ask yourself if you recognize the obtained expression. Thank you very much for your kind attention.